we're going to integrate e to the x sine x with respect to x. This is a very difficult example and may well be considered beyond most courses. However, it does turn up on advanced extension awards and so on, so it's worth going through at this stage. Doing this will also increase your understanding of the parts formula. Here we're going to choose, although it doesn't matter which, v to be the sine x and du dx to be e to the x, although we could easily choose these the other way round. If we then differentiate, dv dx is equal to cos x and u is equal to e to the x. If we substitute into the formula, the integral of e to the x sine x is now u times v, which is e to the x sine x. Take away the integral of the two bottom ones multiplied together, which is e to the x cos x dx. If we look at this integral, we can see that it's of the same type that we had originally. It's no easier to integrate. So we apply parts again. We'll take the v to be equal to the cos x and the du dx to be e to the x. dv dx then is equal to minus sine x, and the u is e to the x. So here we have e to the x sine x. Take away in brackets, this becomes uv e to the x cos x. Take away the integral of minus sine x times e to the x. Minus minus becomes a plus, and so expanding the bracket we get e to the x sine x. Take away e to the x cos x. Take away the integral of e to the x sine x dx. So we have the integral of e to the x sine x equal to e to the x sine x, take away e to the x cos x, take away the integral of e to the x sine x dx. And note this integral is the same as the one on the left-hand side. So if we add the integral of e to the x times sine x to both sides, we'll get 2 times the integral of e to the x sine x dx equal to e to the x sine x, take away e to the x cos x, and then dividing both sides by 2 gives us the integral that we wanted, the e to the x sine x, being equal to a half of e to the x times sine x minus cos x. All we've done here is take out the common factor of e to the x.